Good morning, my dear kids. I'm Sridhar, your physics teacher. In today's chapter in the vectors, we are going to discuss the topic resolution of the vectors. So you might have seen the previous chapter, like we had a unit vector notation. So there we introduced the I cap, J cap, K cap, or any other the unit vectors which we can use them to specify any one direction. And what is the magnitude of them will be unity. After this, today we'll go for a topic called resolution of vectors. I think this will become like a heart of the vector algebra, especially may not be in mathematics, but in physics, I can say that almost in most of the topics will be using this idea of the splitting of vectors or resolution of vectors or resolving of a vectors. So and a better picture of this will definitely will help you a lot in coming chapters. A lot and lot, I can say that. So here a student exclusively has to understand. So as we enter into the two-dimensional motion, projectile motion there I think you can see that the very first topic will start with this. And from there we'll continue throughout the physics. This is something like how that general mass is, similarly the resolution of vectors is what? A essential topic which a student must learn and he should know how to use this. So my focus is more about the significance of it, how to resolve vector and some related numericals, I'll show it. Okay, make some good observation, kids. Okay, we'll start the class. Okay, good morning, kids. Once again, today's chapter, like in the vectors, we are going to discuss the topic resolution of vectors. The resolution word itself, I think we'll try to primarily focus. What do you mean by resolution? What do you mean by resolving resolution? Many things will come. Again, let me directly start with a query. Already previous class, we had a discussion. Once again, I'm bringing here now. So I want to had, so like, let me talk, let me take two vectors. I'm going to define the two vectors here. So let this be vector. Okay, this along very specifically it is there along x-axis, and let there be another vector which is along, so it is making certain angle. So now this is a bar, and this is b bar, which is making an angle theta 30 degrees. What is the magnitude of the unit vectors? You know, the I cap will be unit vector along x-axis. J cap will be unit vector along y-axis. What is the vector a bar? It's very easy. We are going to write, and the magnitude of a, let it be 10 Newton. B equal to, say, let it be 6 Newton. Or 5 as root 30, no? Let me write 8. Then what is A bar? A bar, you are going to write it in a very simple way. A bar is equal to, you are going to write A into I cap, or A into along positive x-axis. Or this will be more clearly, you can write it as A into I cap. And what is value of A? 10 I cap. I think there's a one very systematically you are expressing the vector A bar. There's no problem. You're going to say 10 I cap. What is vector A bar means? You're just going to say that 10 I cap. What about B bar? Definitely, we can't write in terms of I cap, J cap with the knowledge what we have. I'm asking you to write the vector B bar. So definitely you can't say, sir, B bar. So what is the worst thing you can write it? B bar equal to, you can say like a B into making an angle of 30 degree with x-axis. Okay, to some extent. What is this? Making an angle direction, this is the magnitude. Or if you define this as east, okay, if this is the east, this is north, and this is a vector b bar, no? And this is 30 degrees. So b bar vector, what we can write, b bar equal to 10. Okay, 8, no, it is 8. 30 degree north of east. 8 Newton, 30 degree north of east. So what is the 30 degree north of east? That will be direction. Okay, and a bar, we can also write it as a bar equal to 10 along east. Okay, these are the various forms. It's nothing wrong. Say there's nothing wrong. Okay, let me put. There's a method of expressing the vector. What is this quantity? This will express magnitude, and this will give the direction. Okay, so problem solved. Okay, if I just expressing vector, okay. Now I'll ask you find a bar plus b bar. I'll ask you to add. You know the vector addition, parallelogram law of vector addition. What is the formula? R bar is equal to root of a square plus b square 2ab cos theta. A square value 10 square, 8 square, 2, 10, 8 cos 30 root 3 by 2. 100 plus 64, 80 root 3. Okay, this is like a finally 164 root 3 into, I had to do calculation. Approximate 136 will be 80 root 3 is 136 will be 236. Let me add all plus 164. Everything will become root 300 approximate, or this will become 10 root 3. How do you can add east to north of east? Possible. Can you do addition of vectors using this notation along east, north of east? Okay, this somebody is asking, sir, what is this NE? Okay, this is north of east. Okay, now what is that north of east? Okay, can you say this angle? We do mention like this, not east of north, it should be 30 degrees north of it. Now you look at this one. Can you add east to north of east? Okay, sir, okay, fine, no problem, we can do that. Resultant of R bar equal to A bar plus B bar. 10, this in the bracket, I'll write that along east plus this will be 8, 30 degree. We can add this 10 and 8, but how you add east to north of east? No, not possible, no way. Then how to do this vector addition? But how we did parallelogram? So we can't add, no. So therefore, I have to bring some vectors where this B bar is a problem. A bar, there's no problem. A bar, there's no problem. B bar is what if I can bring in terms of I cap, J cap, then I can go for the vector addition. Sir, already this is there. This is by parallelogram law of vector addition. From where I brought it, this is parallelogram law of vector addition. So from there is what we brought this one. Sir, already this parallelogram law of vector addition is why you are doing. So like if I want to add more than 2 vectors, here a big headache. I had to perform this operation twice. So what has to be done now? So therefore, I'm searching for other alternatives. Okay, these are the some. Okay, this is not advisable. We can't hide. So what is the comment? We can't add east to northeast. 30 degree north of east. That there is no such mathematical operations can be performed. No, we should not even think how you can add south to north. Not possible, no. This is nothing wrong, but we can't proceed further. What has to be done? There should be some solution. Our solution is there already parallelogram. No, we want still more better one. That's what we are trying to search in this particular topic. Okay, let's get into. I'll bring those diagrams later. No, let's take one more example. So I'm trying to develop this one. I could have directly entered into the discussion, but why we have to go till there is what I'm just trying to cover the backup story. Okay, there's the x-axis, this y-axis. So we do have there's a path. Okay, that one. So here is what you have: a remote controlled car or a truck or whatever be that. Okay, it is moving here. I think top view, we are seeing this is in XY plane. This is an XY plane, or we can say this is some ant or lizard, anything. So I'll put it. Let me bring some lizard. So some ant, I'll bring it. Okay, what is this? This is the some ant. Okay, it is crawling. It is crawling in XY plane. And hind it is 30 degrees. It is crawling with a speed. Let's put it as like a V, which is equal to 5 meters per second. Now, one of you are standing here, and one of your friend is standing, or your sister. Okay, person, we'll call this a person 1, this is a person 2. We'll ask them, in what direction that particular ant is crawling or moving, we say that. The ant is moving along this specific line. It will move along this line. So now we are asking ourselves question like this person will ask this person's crawling ant. So we'll ask person 1. We'll ask him. So initially it was here the ant. Then after some time it will come here. After some time it will come. We'll ask this person. Will he say anything that it is moving towards me also because it has covered some x displacement? And it will also say that it is also moving towards me because it is approaching me. So instead of moving towards, it say that approaching. So what is the comment of first person? First person said, it is approaching me. He will also comment, it is approaching me. It is approaching me with a certain speed. It is approaching me with a certain speed. The same comment by both. Sir, how come? How come both? Yes, definitely. If you are standing here, so I'll show that this is our ant. It was here, no? It was at certain distance. So after some time, it has come here. Well, let's say that these two persons are at a distance of say like a 100 meters. or say is at 150 meter. After some time, it has arrived here. It has covered 60 meter. Then at what distance it will be the ant? So this angle, this distance x will be, and this will be y. We'll calculate this one. Cos 30 equal to x by 60. So x equal to 60 into cos 30. 60 into root 3 by 2. This will be 30 root 3. Root 3 is 1.7. Okay, it will be 51 meters. Then similarly, sine 30 degree is equal to y by 60. So y equal to 60 sine 30 degrees. This should be equal to 30 meter. So now, initially this ant was here. After some time, certain time, it has come here. No? So how much of distance it has moved horizontally? 51 meter. Able to understand? Now what he says that in time t, it has moved 51 meter towards me or along x-axis. And what he says, it has moved how much? 30 meter along y-axis. So will he say that it is approaching me also? It is approaching me also. The comments are there from them. So now, shall we ask them what is the speed of that ant as seen by person one? Sir, it is equal to v. No, along x-axis. So what is our primary question? With what speed ant approaches person one? The speed of the ant is 5 meter. So next, our question is like, able to understand? No, I'm just putting in a very simple way. It has moved 60 meter along this line. This is a path of. I'll ask you how much it has moved along x-axis means you say 51 meter. How much it has moved along y-axis means 30 meter. Now, so it has undergone some displacement. No, it has moved along x, along y also. Now, what is the speed of the ant with respect to origin? It is 5 meter. What is the speed of the ant as measured by 1? Means it is having certain speed along x-axis. It is having certain speed along y-axis. So what is our question? What is the speed of ant along x-axis? There's a question mark. We don't know that we are trying to do here. Similarly, what is the speed of ant along y-axis? We don't know that. What is the speed of ant? 5 meter per second. But what is the speed of ant along x? Because velocity is a vector. So if it's having a speed along this path, how much along x-axis? Definitely will ask you. So this has to be determined. Very, very important for us. Then you say that if you know that, then you say that person one said that its speed along x-axis is some quantity. Its speed along y-axis is some quantity. That Vx and Vy, we don't know, that we have to find out. Got the idea? So now shall I say that, shall I break up this? A component of velocity will be along this direction. One component will be here. So I'm going to break up this velocity, break up, all split up. I go to resolve. I'm going to resolution it. I'm going to resolve it. I'm going to break up it. I'm going to split up it. Any of the words you can use. Okay, let's get into the main topic which we are supposed to. So let's take the okay, let there be a vector r bar. I'll take contrast colors. There's a vector r bar. Which is making an angle theta. Let's drop, and if you know I have a triangle here. I have a triangle. So let me generate the triangle. Already this is there, no, this is not needed. So according to this triangle, so if you see this is R, this is theta. Let me call this is Rx, the length, this is Ry in this triangle. So from trigonometry, what is cos theta? Rx by R. What is sine theta? Opposite by adjacent, Ry by R. Then how much of its component along x-axis? So here the component of this, I'm going to break it up. Its component along x-axis will be, arrow is needed, yeah, will be Rx. Its other component will be Ry. What is this Rx bar and this is Ry bar? Okay, this will come here. Sorry. What I did, rectangular components it is x, this is y. I just split it up. I splitted up this vector. A component of vector along x-axis is Rx, a part of it, better. Then a part of this R bar along y-axis, that is what Ry. I'm breaking up this vector into two parts. One part is Rx, the other part is Ry. So what I'm doing is like I'll break it up. This will become a part which will be along y, I'll call Ry. This part only will call component. I think all of you know component. So what are the components in a mobile? What are the components in a laptop? Means parts of that one. So what is Ry? Ry is a rectangular component. Why rectangular? Because there's a rectangular coordinate system. So therefore, Ry is, I'll call it as rectangular component. What about again? I'll break up. I'll resolve or I'll split up. Other component will be, other rectangular component will be along x-axis. So what is our question like? What is this Rx and Ry? We have to find out. So shall I break up? Shall we introduce that triangle? Shall we introduce triangle? So what is Rx now? So if you can bring back that triangle, if you complete this triangle. What I did, I just shifted Ry here. So I think the both are similar triangle. No? So what is Rx bar? We can write it. This is a unit vector. How is Rx bar? Along x-axis. This is along y-axis. And this is the theta. This is theta equal to 0 degree line for us. 90 degrees. Okay, let's get into what is Rx bar is equal to. Rx bar should be equal to Rx high cap. Rx is the magnitude. It is along x-axis. What is Rx? Rx will become R cos theta. I am going to call this as horizontal component. Horizontal rectangular component. Let me just call it as horizontal component since it is along x, y, z axis. No, I need not to use word rectangular very specifically. Similarly, I want Ry bar should be equal to Ry j cap. In what action that Ry is there? A component of vector will be along y axis. Sir, why Ry equal to R sin theta from trigonometry? So this is now, what is Ry? Ry will be R sin theta. Now see this. Let's write the vector diagram. Let me write the vector diagram. So looking at the vector diagram, Rx bar, here, I'm asking you to look at this triangle. Rx bar here. I'm moving from tail to edge, Rx bar. Then again tail to edge, Ry bar. Again from edge to tail, minus Ry bar equals 0. So finally, I ended up like this. This will rewrite R bar equal to Rx bar plus Ry bar. Further, what is Rx equal to? R cos theta high cap. What is Ry? R sin theta j cap. This is R bar. So look at the vector R bar. So what are this? These are vector R bar. And this is any name horizontal component of vector R bar. There's a vertical component of vector R bar. So what is Ry we should call? Component, part of it. Very simple. I am able to break up that, I'm able to split up that vector into two parts. What is a part of vector along x-axis? R cos theta. Part of vector along y-axis? R sin theta. The same words. Let me keep it here. I think it's very good. No, indirectly what we did, we are able to break it up. We are able to split the vector. So what do you mean by components? Part of a vector. So this particular process is called as resolving of vectors. We are able to break up a vector, a component of it along x-axis, r cos theta, a component of it along y-axis, r sin theta. What do you mean by here theta? Theta is what reference I put it. This is theta equals 0 degree line. In what action horizontal component will be along theta equals 0 degree line? In what action vertical component along theta equals 9, not along y, along x. So what is the rule here? Horizontal component, horizontal component will be along theta equal to 0 degree line. What about the vertical component? Will be along. Okay, the component which is along theta equal to 90 degree is vertical component. A component which is along theta equal 0 degree is horizontal component. We are not saying about the physical horizontal vertical, or not along x nor along y. Okay, indirectly what we did, we are just, what is this? These are the parts of this vector. I don't want to talk much here. I don't want to speak much here. Sir, what is R cos theta, R sin theta? They are the parts of this R bar. So if you want to write that comment also, nothing wrong. R cos theta, R sin theta are parts of R bar. Okay, at least now. So what we did, the R bar vector, we are able to break it up into its parts. What are the parts? A part will be along x-axis, a part will be along y-axis, or components, what we call them. Now, if similarly, if a vector is there, if there's a vector, we'll go back to the questions which were earlier asked. We have to answer all of them. Now there's a vector which is directed along this direction. So there's a vector, say like a bar, which is making angle 30 degrees. See now, it is making angle 30 degree with y-axis. It can. I can mention it in this way also, or we'll bring it here. Now, which is theta equal 0 degree line? This is theta equal to 0 degree line. And this is theta equal to 90 degrees. How to resolve? So what is the method? A cos theta horizontal, look at this horizontal component. So ay is equal to a cos theta. A is how much? Okay, let's take a equal to this is 30. 10 root 3, I'll write it. So this will be 10 root 3. Why to bring 10 meter, we'll write it. So this will be 10 root 3. So 5 root 3, it is there. So what is AY bar? AY bar will be 5 root 3 J cap. Similarly, AX will become A sine theta. Because this is theta. You can ask questions of where is theta? Okay, I'll write theta. Now A sine theta, what is value of A? 10 sine theta 1 by 2. Okay, this will become 5. Now what is AX bar will become 5 high cap. Now you can see this. So sine theta, which is horizontal, which is vertical component. That was the primary question. Horizontal component should be along theta equals 0 degree. No, this will become horizontal. I think that here is what a lot of students will get confused. So what is the comment I should write? This is the horizontal component, and this is what vertical component. What is the total vector A bar? Let's get into the thing. So when you split up A bar, what you get it? I'll bring one more diagram. Here you will get AX bar. This is AY bar, and this is A bar. So again, rewrite in the vector form. AX bar, AY bar, and this is the resultant A bar, which was making angle theta with y-axis. So then how you write this vector A bar equal to AX bar plus AY bar, the similar fashion. So this should be equal to how much? 5 I cap, 5 root 3 J cap. Anyway, say vector, will it makes angle 30 degree with x-axis or with y-axis? Let whatever be that one. Now, which is the horizontal component? Which is the horizontal component? This is the horizontal component. This is a vertical component. Horizontal doesn't mean that with respect to physical thing. Horizontal here and vertical is with respect to theta equals 0 degree, theta equal to 90 degree. But sir, like previous problem, you made this as horizontal component, I cap. Yes, because the theta equals 0 degree and you took this is x-axis. Okay, now you got the idea. The horizontal component is not something should be always along x-axis. It can be along y-axis also. It all depends upon what point you define theta equals 0 degree. That was the main purpose here. This is the vertical component. This is horizontal component. And this is a vector. Okay, hope everyone is able to now resolve the vector. Nothing is there. Along theta equals to 0 degrees, r cos theta or a cos theta, along theta equal to 90 degrees, a sin theta. This was the splitting of vectors it is called as. Now our query was what like? What was the speed of the ant? Can we find out this? What is the speed of the ant as seen by person 1? With respect to person 1 means. What is the speed of ant along x-axis? See how I'm using along. Ant is moving in a plane, but how much is speed along x-axis? So I'm just going to resolve v cos 30, v sin 30. Now I think we are in a better position. So this diagram, I will take it here because if I yeah, we'll paste it and we'll answer it now because that was a question. No, we'll answer now. No, he will say that it is approaching me with a speed. He will comment now. So look at the ant is moving. It was here, no? It will move like this. Now, what is the speed along x-axis? There's the thing. So shall we go for? No, Vx equal to V cos theta I cap. V is how much? 5 cos theta root 3 by 2. Okay, let me keep this much here. Then what is Vy equal to? V sine theta j cap, which is equal to 5 sine 30 will be 1 by 2. Meter per second. Unit also I should mention. So now what we should call this? Speed of the ant along x-axis. What is the speed of ant along y-axis? So what we commit, it is approaching me with a speed 5 root 3 by 2 meter per second. It is approaching me with a speed 5 by 2 meter per second. I think they're able to answer now. So it's, I think, something quite very important. No, we are able to assess the speed. What is its component? So what we should call this is x component of velocity, y component of velocity, later part. So here you can call this horizontal component, this is a vertical component. So once again, what is a resolution of vector? Splitting up of vector, breaking up of vector, or breaking up vector into its parts or into its components. Here, y rectangular component, because along x and along y, we are splitting up. That's why it is called as the rectangular components. These are Vx and Vy. Okay, now in general, okay, we'll take some, these are the, in our day-to-day life, we do come across all these things. One by one, we'll take example. Okay, this person is pulling his bag with his arm. Okay, he's pulling his bag. There's a bag, no? So tell me, like, how much of horizontal force is applying on the bag? So these are the primary questions we're asking. Find the, okay, we'll ask this horizontal force exerted or applied, horizontal force applied by person on the bag. I think it should be equal to Fx, F cos theta I cap. With his arm is pulling this, is holding this handle and is pulling it. So how much F cos theta I cap? This is what? No, horizontal force applied by the vertical force applied. Vertical means upward. A component of force will act upward also, F sine theta. Vertical force applied by the person on the bag should be equal to Fi bar equal to, very cleanly we are able to tell all these things. So how much of force is actually dragging the bag with by holding his handle with a force F through his arm. How much of force acting on the bag along y-axis? We are able to tell now. Sir, is it applying force F? Is actually is pulling the bag with a force F, but I'm asking here how much along X? You are able to tell. So what is it? What is this F cos theta? This F cos theta is a horizontal component of the force acting on the bag. F sin theta, vertical component of force acting on the bag. So can you show that F cos theta, F sin theta? Yes, we can show it. Okay, let me bring. Only bag, I'll bring it because I wanted to show clearly only the bag one. What was the force? The force that was acting here was We'll agree this. So this is what that F, how much horizontal component. This is a horizontal component. How much vertical component? There's a vertical component. I'll make it thick so it'll be visible for you. Oh, yeah. You see this now. So what is this? This is what F5. Are we able to, okay, for a back, can we calculate as we are able to split up that force? Okay, similarly, I'll take the truck. That's here, okay, dog also. So you have, see, it's not that something mere mathematics. That's what the students, what they think, A bar, B bar. Day to day in your day, everyday life, you do come across several examples. Okay, there's sometimes you might have seen, no? Like some block or something, there's some truck which will pull that heavy block. Then here in the strings, a force is set up and this is acting at an angle. So what are the forces that are acting on the string horizontally? So F cos theta. The string will exert a force and this is F sin theta. The truck which is moving is pulling the block and the forces acting on the block will be F cos theta, F sin theta. How much of vertical force exerted by the rope? This is the rope. So what this particular heavy block, you can say there's a block means heavy block it is. So what this particular rope will do? So I'm going to pull this block using this truck, this setup what I made. Then here some force is set up in the rope. A component of force on the block will act horizontally, other component will act vertically. So if I ask you what is the force exerted by the rope on the block horizontally, F cos theta. This other component. So I'm just going to split up now F cos theta, here F sin theta. Similarly, if a dog chained, I think have a space, let me explain here only. There's a dog. So it will be chained to certain wall. The wall is not getting displayed. I'll put a wall. This is the wall. Oh, something bad happened. Oh, no. The dog, what it will do? It will try to move away from wall. No, usually they don't keep quiet. Then what are the forces, sir? Can you show forces? Yes, here the force will act in this direction. Here it will be like this. Later part in the laws of motion, you are going to learn why the forces will be in this direction. So let this be theta. Let me define this way. Then what is the horizontal force exerted by the chain on the dog? It should be F sin theta. What is the vertical force exerted by the chain on the dog? F cos theta. Sir, can you show that arrows once again? Okay, this is what the arrow, there's a vector. A component of force, F sin theta, will be on the dog acting horizontally. And again, I'll break up. F cos theta is the force exerted by chain on the dog that will be acting vertically here. This I'll split up. A part of force will come here. A part of force will come here. I can show it here. Some red color arrow, I'll take it. Huh? That will be more visible. You can see that this particular force, I'll break it up, F sin theta. I'll break it up, will become F cos theta. Like that, I can split it up. We'll keep this F. It'll be easy for you. So what is F cos theta? Force exerted by the chain on the dog vertically up. What is F sin theta? Force exerted by the chain on the dog horizontally. So in everyday life, almost 4 examples are given. The resolution of vectors is related to our everyday life. You'll be pushing some table at an angle. You'll be pushing the wall. Everywhere, what happens? Start analyzing now. Compare yourself. You'll be pushing some wall at an angle. Start thinking, okay, what is the force I'm applying on the wall, parallel to wall, perpendicular to wall? This is what needed here. A student has to, what all he learns something, no, he has to go back. Oh, this is what I'm learning. He has to compare with the general things. Okay, so somebody is asking. Okay, see there. These are the examples what we are giving you. Okay, after this, we'll take some problems, how to resolve, and we'll see that, and also we'll check it, what is the advantages of these things. I will take one example, addition of, like how this resolving of vectors will really going to help us a lot in our studying the concepts, especially in the vector algebra. That's what I'll try to demonstrate with the help of some examples here. So there's a one vector. Say this A bar is 6 Newton. Next, I have another vector, B bar, which is 8 Newton. So I'm just asking, find, and the angle between them is theta 30 degrees. So here, for our convenient, if you don't want to like, okay, just leave it. And there's a unit vector which will be directed along x-axis. There's a unit vector directed along the axis. What is the question? Find A bar plus B bar. Directly, primarily, straight away. Okay, so now how to add two vectors? I think we are very good. We have done enough of mathematics. Where that enough of mathematics? Parallelogram law of vector addition. So the resultant, how the resultant? Okay, let's first calculate all the things. R is equal to, from parallelogram law of vector addition, if you check it, we'll get A square plus B square 2AB cos theta. Let me substitute all the values. The vector A as given 6 Newton, B is 8 Newton. Let's assume some vectors of certain magnitude. A is 6 Newton, B is 8 Newton. So this will be 6 square, 8 square, 2 into 6 into 8, cos 30 root 3 by 2. Solving this, 13.53 Newton. This is resultant. So what about angle? What angle it makes? So the angle also we can calculate. Tan alpha is equal to B sin theta, A plus B cos theta. Substituting this value of B 8, sin 30, 1 by 2, A is 6 plus 8, cos 30 root 3 by 2. So this will end up something 4 by 6 plus 4 root 3. Then alpha, I'm using calculator. I'm doing this fast calculations using calculator. So alpha will make 17 degrees. What is alpha? The angle made by the resultant. So where is the resultant? Can you show resultant vector? Yes, resultant vector will be here. It should make an angle. How much? What is the length? 13.53. There's a length. Okay, sir, I'm I'm very good in parallelogram law of vector addition, and I'll just do by this method, problem solve. So why I should study resolving of vectors? No, nothing wrong. I'll show the resolving vectors. Of course, for that, what you should be very good in what, like these formulas, everything. If you don't know these formulas, no way. Can we do this same by any other alternative method? Resolving of vectors, we'll see. So if you go for the resolving of vectors, the first A bar vector is done. We have to resolve the vector B bar. That is what the difficulty what we have. The vector b bar is making an angle 30 degree with x-axis. So what are its x components? Its x component, I'm going to break up this vector. A component of this will be here. The other component, any color? I'm getting confused. Okay, we'll take it brown color. The other component will be here. So what is bx bar, by bar? What we are doing? So once again, so what you are doing? I'm just splitting up this vector. This vector is, if I split up, a part of it will be along x-axis. Then a part of it will be along y-axis. So the one which is along x-axis will become horizontal component. The one which is along y-axis will become vertical component. In position of vector. No, one which is along x-axis will become horizontal component. This is bx. The one I'll split up, vertical component. This will be along y-axis, that is by. That we are trying to find out. So what is the value of like a b bar? So again further, if you know the vectors, it will be like this, no? Bx, by, and this is what b bar. This is theta. So how you write b bar? As the vector b bar, bx bar plus by bar. Bx bar in what direction? Along x-axis. Which unit vector will be along x-axis? I cap. Which unit vector is along y-axis? J cap. So bx bar can be written as now this b bar. I'll expand it. B cos 30 degrees I cap. B sine 30 degrees J cap. What is the value of B? B is, as we know, 8 Newton. 8 cos 30 root 3 by 2 I cap. 8 1 by 2 J cap. So this will be 4 root 3 I cap 4 J cap. Okay, there's a value of this one. So now what was our question? Find A bar plus B bar. Do we know A bar? A bar is very simple. 6 I cap. Then I want the resultant of A bar plus B bar. So let me try that one. The resultant R bar equal to A bar plus B bar. What is A bar? 6 I cap. What is B bar? 4 root 3 I cap 4 J cap. So root 3 is how much? Okay, this will make them common. After this, 6 plus 4 root 3. What you can write it as 12.93. This is R bar. But Salake, we were supposed to get the value of R 13.53. I think if I take this. If I take under root of it, solving all this, I'm using calculator. Finally, I'll end up with this one as 167.2 plus this is 16. So the rough value of this will be 13.53 approximately. Same answer. Then what about the tan alpha, sir? How you find out tan alpha? Let's see. How we'll find out tan alpha? Yes, for that also I have a method. For that also I have a method. So what is the method we will follow? Let's move this a little bit here. No. No, we'll go for, look at this vector R bar. This R bar, you can write it as this component you call X component. This is Y component. So then the vectors will be Rx bar. This is Ry bar, and this is the resultant. This alpha, tan alpha, Ry by Rx. So Ry is 4, 12.93. Solve it, you'll get alpha, the same value. Okay, now see, maybe you may find, so there are two methods are there. What are the two methods? The two methods is, I'll put boundary here. How we did the left hand side? The left hand side was did by parallelogram, law of vector addition. How we did resolving of vectors. Now, finally, you may ask, sir, like maybe the right hand side one was a little bit lengthy. This problem may be lengthy, but as we go for coming, I'll give a few more problems. This will be very, very difficult. Two vectors, okay, this is fine, parallelogram. More than two vectors, very, very difficult. Any number of vectors, resolution of vectors, very easy. Within few minutes, what happened? You can get the answer. So now we can do vector subtraction very easily, vector addition, subtraction, what will be that? We can easily, conveniently, we can work out any number of numericals, especially the algebra, the adding of vectors. And whose help I'm taking? The ICAP Jacob. Now you have to ask questions, how, how you're drawing triangle. Look at the resultant. It is clearly telling that it lies in the first quadrant. So therefore the triangle will come in the first quadrant, the resultant triangle, this one. This component of resultant along x-axis, I'll call Rx. Component of resultant along y-axis, I'll call Ry. So that will be easy because I could have written here 12.934. Again, looks odd. Therefore, I give some symbols. You see, finally, we got the answers. Both the methods are there. We got the answer. Both the methods are there. This is the same answers will get it. Due to some here and there approximation, slightly they differ, but okay. Like this, a student has to compare and he has to finally say that, okay, which was the better, when to use which one is what he has to have a general conclusions. That's the only thing is what a student has to analyze thoroughly here. I'll give one more problem, then we'll see, can you really show by parallelogram law of addition? Let me give one more question. Okay, there's a vector A bar, then the vector, there is a vector B bar, and we have another vector C bar. I'll ask you to find out the resultant of these three vectors. I'll bet you definitely prefer resolution of vectors only. We'll mention unit vectors so that it'll be easy for you in writing equations. There's a vector A bar, B bar, there's a C bar. This will make an angle 30 degrees. This is 45 degrees. The value of A is 8 Newton. B is 4√2 Newton. C is 2 Newton. Find 2a bar, 3 bar plus c bar. First priority is what, like parallelogram law of factorization. So there what is the problem we'll encounter? First, I should find out a bar plus b bar. The resultant, let me call R1 bar. Again, twice I should apply. Again, I should find out the angle made with the resultant R1 bar. It will come somewhere here. Again, I should measure the angle between R1 bar and C bar. Again, solving. So it's a big headache, no? It's a very, very big headache. So resolution of vectors will solve your problem like that. Before that, we should get the B bar and C bar vector, because A bar is okay, fine. B bar is, we don't know vector, only magnitude and direction we know. We have to generate a vector. Okay, B bar. It will be equal to B cos 45 minus I cap. B sin 45 plus J cap. Yeah, what actually happened? This B bar vector, I'll split it up. I'm just bringing, so what I'm doing is, okay, there's a B bar, a component of vector along negative x-axis, B cos 45, and how is B cos 45? Along negative x-axis minus I cap. A component of vector along positive y-axis. So therefore, this will be how much? B sin 45 J cap. So minus I cap, I'm not seeing. So this will be minus I cap. This will be minus J cap. Unit vectors. So we'll substitute the value. So this will become B bar. B is 4 root 2 1 by root 2. This high cap. This will be 4 root 2 1 by root 2 J cap. So this will become minus 4 I cap 4 J cap. Okay, B bar, I got it. Then similarly, C bar will generate. C bar will be C cos 30 degree minus J cap. Again, big trouble for you. Sir, here for I cap, you took cos. For I cap, you took cos, you see it. For J cap, you're taking cos. It's not like something rule that one. No, this will become horizontal component. This will become vertical component for C bar. Already we have discussed. So this will become C sine . Okay, value of C is 2 root 3 by 2 minus J cap 2 minus I cap. So this will become minus I cap minus root 3 J cap. Both will be. Now, what was the question? We have to find out the resultant of all this one. No? So I'll directly jump into the calculation part. Here, let me do it. R bar is equal to A bar plus B bar. Okay, that's the equation. 2A bar plus 3 bar plus C bar. 2A bar is what? 2 times of vector A bar. A bar, did we define A bar? We'll define that A bar also. A bar is just mere 8 I cap. So 2 times of 8 I cap. Then 3 B bar minus 4 I cap 4 J cap. C bar is 16 I cap 12 I cap minus I cap plus 4 J cap. All the cap terms, all the unit vectors I cap, I'll make it common. 16 minus 12 minus 1. This is I cap. This will be 12 minus root 3 J cap. This will be 3 I cap. 12 minus root 3 is 1.7. So 10.27. This is R bar. Okay, this we wanted the magnitude also. Let's see that. And what about the angle also? So the magnitude is given by so this will become 10.7 Newton, the final value. I'm using calculator. I'm not not possible. By seeing we can't tell. I'm using calculator, fast calculations I'm doing. Okay, this is the resultant of these two. A bar plus B bar, this equation. I want the angle. So for that, what we'll do again, this R bar only, this can you write it as Rx I cap, Ry J cap. In place of Rx, what you have 3. In place of Ry, it is 10.27. So, and the vector diagram will come here. Rx, this Ry, this is the R bar. Let me just shade those things. It'll be easy for you, comparison. So Ry is this, Rx is here. This is what final angle alpha. So tan alpha. Ry by Rx. So Ry value we know 10.27 by 3. So solving this using calculator finally will end up 73.7 degrees. You try to solve this by parallelogram law of vector addition. Very difficult, very difficult. You'll get it, but you have to struggle. So I think this is still the best thing, no? What you have. I feel this answer. So sir, can you show where is R bar? So the R bar vector, where it will be, it is going to be. So the final diagram, let's, because this will retain, no, there's a question. I think I'll paste it here. Our R bar will be 10.7 and it will make 73.7. It is like this. This is what R bar. And this is alpha. Hope everyone is able to understand the significance of resolution of vectors. That was the main purpose. Why I'm putting effort all this much is like to make students to analyze. Okay, the resolution of vectors is there's an idea, there's a use of it. We must learn. There's a vectors. Now, can we do, there's a vector addition as shown. Can we do vector subtraction as the same question slightly? Let me change it. Let me just slightly modify so that you'll understand how powerful is this particular method is. What I am, can we do subtraction by using same thing? So here, slight change I'll bring. Instead of 2a bar minus plus 3 bar, no, let me bring negative. I'll ask you, okay, come on. Find out the resultant of these 3 vectors. Already we know a bar, b bar, c bar. The same idea, no? Directly we'll go for the resultant. So do we know a bar? What we have struggled ourselves to get this one. All these equations, I'll take help of. B bar, we know it. I'll just paste it. Already previous problem data, no? That let me use that one. C bar is this. There's a C bar. And what is A bar? A bar is 8 I cap. This is very easy. Anybody can find out. Okay, let's keep this everything in one corner, or so let's bring it here, nearby diagram. This is about the, by looking at the vectors, we are able to gather this much of information. And now, what was the question that is asked? Find the resultant of, find the value of 2A bar minus 3 bar plus C bar. Let me directly write it. R bar equal to 2A bar, 2A bar, 2 into 8 I cap, B bar minus 4 I cap for J cap, C bar. Then we will change all this. So this will be 16 plus 12 minus 1 I cap. Then this will be minus 12 plus root 3. This will be J cap. So 16 plus 12, 27 I cap. Uh, 27, this will be the value 27 I cap minus 13.7 J cap. This is the overall, the resultant. Okay, after this, what shall I do now? We have to calculate the magnitude. 27 whole square plus minus, or what you do with negative sign. Okay, doesn't matter. Solving this, I'll end up with 30.3 Newton. What about, sir, can you show the vector diagram? Okay, this is R bar is there, no? So this we can also write it as Rx I cap Ry minus Ry J cap. So why you took negative sign? Because you look at the component, this will be there along negative y-axis. So where you should draw the triangle? Now the triangle has to come in. The triangle has to come in. So this is Rx. This is Ry. The triangle will be here. So how you can show that the triangle will be there in the fourth quadrant? Let this be alpha. So why you are drawing this triangle? There in the previous problem, first quadrant, here fourth quadrant, looking at this resultant vector, I cap minus J cap. So the vector will be there in the fourth quadrant. So this will be X component, this is Y component. This is X component, it is here. This is a Y component, it is here. Now tan alpha. What is Ry? Ry is negative value. We have to substitute. Or if you want, you can avoid that sign also, no problem. Alpha will be negative, that's all here. So if you solve this, alpha will come minus of 27 degrees. What does it mean alpha, sir? You are measuring alpha clockwise, or else you can already have shown that in triangle, no necessity. You may get confused. If you want, you can retain, or just you are indicating everything in the triangle. That is enough. See now, can you solve this by parallelogram law vector addition, the formula? Very difficult, no? First you have to multiply vector A bar. Then you have to do subtraction. Then the resultant will come, that you have to add up. Very, very, very difficult and lengthy. Simplified one. This is a use of resolution of vectors. You can resolve, not only this, you can resolve anything, any vector, let it be in anywhere. Let me give some other general examples. If there is a vector, okay, there's a thing, okay, there's a vector. Okay, there's a vector. Can you resolve this vector along along this incline? This will be, this is called as the incline. I'm asking you to resolve this vector along the incline. Along the incline means how much component will be along the incline and how much of component will be perpendicular to incline. How to resolve this? Okay, the force. It's not that only XY axis. It can be anything. Let's try to resolve here. So what is theta equals 0 degree line, sir? What is theta equals 0 degree line? Here already I indicate theta. That is the angle between the inclination. Angle of inclination it is. So here if you look at the basic mathematics, you take a perpendicular. Then further you introduce like this. This is the inclination. The inclination is this one. From the data available, this is theta 90 degree, 90 minus theta. So therefore this should be theta. So component of force along this, I'll call F perpendicular. Component of force along this, F parallel. F parallel will be along the incline. So sir, I'm not understanding what you are doing. So what I did, this was the force, no? A component of force I resolved, that is F perpendicular, perpendicular to incline. There's a force F. A component of this force I resolved, that is along the incline, that is F parallel. I think no problem. So I'll show by different colors at least. Okay, there's a one. Not visible. Like this, you can resolve it. No. Okay, what is this F perpendicular? We have to say F perpendicular equal to F cos theta. F parallel equal to F sin theta. And sir, I'll define this unit vector, will call as E parallel cap. The unit vector perpendicular to this will call E perpendicular cap. Then how you write F bar? F perpendicular, E perpendicular cap, F parallel, E parallel cap. Carry on now. So it's not that I cap, J cap. Here we have introduced that perpendicular. So these are the ways in which we are going to deal in the laws of motion. So many numericals will come where we have to split up the force to analyze the motion. If a vector is there, I should split it up. How much of that force along the incline, perpendicular incline, then be very easy to study the motion. So therefore we are using this one. So once again, what do you mean by a vector? Or what do you mean by resolution of vector? Resolving it into its rectangular components, or breaking up into its rectangular component, or splitting up a vector into its rectangular components. This was the resolution. Then how horizontal component will be along theta equals 0 degree. How vertical component will be along theta equals 90 degrees. Okay, there's a one very fundamental which will be widely using in the remainder of physics. Okay, kids, like I introduced you to the resolution of a vectors into its rectangular components. I think this is something very fundamental vector property which will be widely using in the remainder of the physics, in the rest of all the physics, in almost you can say every topic. So just try to understand what is the significance of it, to what extent we must have the grip on that one. So therefore you go for the wide varieties of numericals, think on them, analyze them, compare them, so that you'll get exact picture. Oh, this is what the resolution means. And as you get into the kinematics, two-dimensional kinematics motion, the very first is what this resolution is what will be used. It'll become very small thing later on. As you keep on practicing, it'll become very easy for you. Okay, we'll meet in the next class. Okay, thank you all of you. take care, bye, see you.